Good evening, everyone. I thought I'd make a really quick, simple video on rainbows. Now, a lot of you, your whole life, have always wondered why that rainbow is in the shape of a dome. Why is it always arched? Okay, what I'm going to be showing you in this video is how that rainbow is formed, what causes that rainbow, and also at the same time what causes the double rainbow above it. And it's really simple. Now, science will tell you that a rainbow is caused by sunlight and atmospheric conditions. Light enters a water droplet, slowing down and bending as it goes from air to denser water. The light reflects off the inside of the droplet, separating into its component wavelengths or colors. When light exits the droplet, it makes a rainbow. Okay, now for the most part, that's true, but what they're not telling you is that the raindrops are only there to work as a screen to capture what's being projected, okay? Now, in order to understand this, you have to be able to understand what refraction is. Refraction, deflection from a straight path undergone by a light ray or energy wave and passing obliquely from one medium, such as air, into another, which is glass, in which its velocity is different. Now here's an example of refraction. The white light has to pass through a prism, which is usually a glass or a crystal or a mirror, and cause the colors to come out, which, as you can see here, I'll break it down for you. The prism would be a glass of some sort, and it has to hit that glass and refract, which will make the colors, as you can see here in the rainbow. Okay, now that you understand what refraction is, I'm going to show you how this rainbow is formed. Now, what you got to tell yourself is, and we all know this, we've never seen a straight rainbow. We've never seen a rainbow going up, down, or down to up, or left to right, or even diagonally. It's always in the shape of an arch, in the shape of a dome. So here's what you have to remember. The white light is reflecting through a prism, which has to be glass, something of a glass form. So whatever that sunlight is hitting, when you see that rainbow, it's the shape of the prism that it's hitting, which is the glass firmament, the glass dome. That's why it's shaped the way it is. Now, the rainbow is always there. You just can't never see it unless it rains. The raindrops act as a screen, like if you were projecting a movie. The movie could be playing through the projector all day, but if it doesn't have a screen to reflect off of, you can't see it. But what you have to realize is the rainbow is always there, but the only time you see it is when it rains, because the rain acts as the screen. Like right here, check this out. There's always a rainbow out here. Now, if I take this water hose and I turn it on a mist, that mist makes a screen of water across the air, and it shows the rainbow, the reflection. Notice even right here where I'm at, it's still shaped like a dome. It's rounded because that's the shape of the prism that the sun is reflecting off of to give us this rainbow. It's really simple, folks. And like I said, it's in 3D also. You know, no matter which way you turn, that rainbow's always there as long as you got that mist of water to give you your screen. So, are you with me so far? And if you are, now I'm going to take you deeper into the rabbit hole. Now, you thought you were awake before? After I show you this, you're really going to be awake. Okay, here we have a rainbow over the ocean. Now, what I want you to pay attention to is the reflection of the rainbow over the water. Notice how the colors are inverted, which means reversed, backwards. Notice how the colors go backwards from the original rainbow on its reflection in the water. So we know in our simple common sense that that's a reflection of the rainbow, so it automatically reverses the colors. Just like if you and I looked in the mirror, the left side of our face would be the right side of our face, right? Okay, now that you understand that, look at the double rainbow. Look at the rainbow on the outside of the original rainbow. Notice how the colors are reversed, just like they were when you seen the rainbow over water. That's because the firmament is the glass prism showing the reflection of the original rainbow. That's why the colors are backwards. Now, as you can see here, I've made a rainbow of colors on a piece of paper, but I'm showing you how the colors invert, how they reverse when I hold it in front of a mirror. Therefore, proving, just like you've seen over water, when those colors are reversed, that's the reflection of the rainbow in the firmament above. Now, if we look up how to make a rainbow inside, here's what it tells us. We need a flashlight or a sunny day, a mirror at least 5 by 5, a pan of water, a CD, and a prism. We use this one, Tedco Light Crystal Prism 2.5. Now, here we go. I'm going to go through this really quick. We're going to fill the bowl of water. We're going to use the mirror. You have to remember that the mirror is flat. It's straight and flat. So therefore, our rainbow, which is going to reflect on the wall, which would be your raindrops, your mist, which would be your screen. Check this out. It's going to be a straight rainbow, a straight line, okay? Because it's a straight, flat mirror. Now check this out. If I take a round dome-shaped glass and let the sunlight shine through it, guess what I get? A rounded, arched, dome-shaped rainbow, just like you see every time it rains, because the raindrops give you a screen to see what's projecting from above. And just like I showed you before, the rainbow is always there. You just need a screen to capture it, just like you always need a movie screen to capture what's being projected out of the projector. The movie that's being projected, it's always there, but you need a screen to capture it, like you see right here. Now I want you to watch these couple science jerks try to explain a rainbow to you.
Now let's talk about that. What's happening inside of our rainbow?
Let's take a look at another raindrop here.
This is a big raindrop.
Big raindrop, cut in half. The light from the sun comes in like so. It enters this side of the raindrop and it starts to bend into its colors right here. It bounces off the back of the raindrop, goes out here, bends again, and spreads out even further into the colors. Now what that means is that it makes a very definite angle here between the incoming light and the refracted or spread out light. And that angle is about 42 degrees. Roughly.
So you have to have at least that angle or that angle to create this bending and bouncing to come out like this.
So as you can see, you have a couple of science geeks here trying to explain to you a rainbow through a raindrop, but yet they're not showing you a whole raindrop. They are cutting that raindrop in half, which leaves what? A dome-shaped raindrop, to demonstrate to you how the rainbow makes a curved shape.
Let's take a look at another raindrop here.
This is a big raindrop.
Big raindrop, cut in half. The light from the sun comes in like so. It enters this side of the raindrop and it starts to bend into its colors right here. It bounces off the back of the raindrop, goes out here, bends again, and spreads out even further into the colors.
So here we are with science, once again, cannot duplicate what they're trying to explain, just like they can't duplicate a spinning ball of water. And they never will, just like they cannot duplicate a raindrop refracting the sunlight. They have to cut it in half. But I duplicated it in real time, and you've seen it with your own eyes. The only way that you can get that type of reflection is when the sunlight, the white light, passes through the glass prism and refracts the colors. And those colors will be in the shape of whatever prism, whatever shape the prism, the white light, the sun, is shining off of.
And God said, "Let there be a firmament in the midst of the waters, and let it divide the waters from the waters." And God made the firmament, and divided the waters which were under the firmament from the waters which were above the firmament. And it was so.